In the last video, we figured out the derivatives of the remaining 4 of the 6 trig functions. So now we can take the derivative of any of our 6 different trig functions. And we proved those, or derived those, using some facts from a trig class. Namely, that you can write any of the trig functions in terms of sines and cosines, and this Pythagorean identity can help you simplify some stuff. That knowledge, along with the quotient rule that we developed in the last section, allowed us to come up with all these different derivatives. But you don't want to derive these derivatives every time you need to use them. So what I'm going to do in this example is assume that you know these 6 facts. And really we'll focus on the 4 new ones. These are 2 that you had from the past. If you already know those facts, you can take derivatives that involve those facts fairly easily. For example, if somebody asked you to take the derivative of 5 times the cotangent of x, what you would do is, remembering previous rules, treat this 5 as the coefficient. So it's 5 times the derivative of the cotangent of x. And then stare at that for a minute. It's tempting to change cotangent into cosine over sine, but don't do that. You don't need to rewrite this in terms of sines and cosines as long as you know that the derivative of cotangent is negative cosecant squared. So I can do this as a one-step process and just change that cotangent into negative cosecant squared x and be done right here. Okay, I say done, but really I wouldn't finish right there. There's no reason to write these parentheses. 5 times negative cosecant squared x is the same as negative 5 cosecant squared x, and this is a little bit easier on the eyes, so I'd probably stop at this stage. The point is just, as long as you're not trying to rederive these facts, as long as you have these memorized, this first example is pretty damn straightforward. What about this second example? Well, this one might be a step more complicated, but I think you'll find that it's manageable. What we have here is the derivative of something plus something else. So I'm going to break that up into 2 different derivatives using my derivative sum rule. However, note that the first thing has a coefficient, the number 10. So I'm going to pull that out in front of the derivative symbol using my coefficient rule. What I'm saying is, if I'm asked to determine this derivative, in my head, I'm thinking this is 10 times the derivative of x times the cosecant of x plus the derivative of 1. Note that my parentheses are all appropriate. I don't want parentheses here, for example, because I don't want the 10 to get multiplied by the derivative of the 1, because the 10 is not being multiplied by the 1. The 10 is just being multiplied by the x and the cosecant of x, so I don't want those extra parentheses. I want to write things this way. Are these derivatives I can figure out? Absolutely they are. The derivative of 1 is super easy because 1 is a constant, and the derivative of any constant is 0. So this whole thing's just going to go away. What about over here? Well, I have 10 times this derivative. This derivative is x times the cosecant of x. It'd be nice if you looked at this and immediately recognized that you got a product rule. When I use the product rule, it's going to end up giving me 2 different terms, so I better put these parentheses here so that the 10 hits both of the terms. I got the derivative of the x, which I know you know the derivative of the x, but I might encourage you to write derivative of x instead of just 1 here to really show your work and detail that you're using the product rule. Derivative of the first thing times the second thing plus the derivative of the second thing, cosecant of x in this case, times the first thing, the variable x, plus 0 if you really want to show what's happening to this derivative of a constant. I still got some d over dx symbols, so I still got some work to do. I got 10 times the derivative of x is just 1. 1 times cosecant of x is just cosecant of x, plus the derivative of cosecant of x. Maybe think back to your list, see if you have this memorized. For what it's worth, I have memorized that the derivative of secant is secant times tangent, and from there I remind myself that cosecant is cosecant times cotangent, except it's negative. So I'm adding a negative, so I'm going to write a minus right here, and then I'm going to write cosecant times cotangent times x. And usually when I just have an x floating around, I like to write it at the start just because it makes things a little bit prettier. So I think I would write things this way, although you don't have to. Do I need to go any further? Absolutely not. Could I go any further? Yeah, I guess. I mean, if you don't like parentheses, you can get rid of the parentheses by distributing the 10. If you're cool with parentheses, you could leave the parentheses there and maybe recognize that you have a cosecant in each of these terms and pull that out in front as well. So another alternative way of writing this, certainly not better, but I don't think it's worse either, is 10 times cosecant of x times 1 minus x cotangent of x. In a trig class at this point, or maybe back in this point, I encouraged you to try to simplify this by changing everything back into sines and cosines, changing your cosecants into sine and cosine, changing cotangents into sine and cosine, and see if things canceled out. In a trig class, they always seem to cancel out super nicely because the teacher wrote the problems in such a way that they would cancel out super nicely. I think what you'll see in a calculus class is seldom do they cancel out very nicely because the expressions that you come up with are already simplified. A cosecant and a cotangent can't simplify at all, which is why we don't write this in a different form. It's why we leave it as cosecant times cotangent. So yeah, you could rewrite this in terms of sines and cosines if you felt the need, but I probably wouldn't bother. I don't think it's any simpler. It's just a different way of writing the answer. Let's see if we can squeeze 2 more examples into this video. What if you're taking the derivative of tangent of x times cosecant of x? At least 2 options here. Option 1, you're like, I'm so good with calculus, I'm not even going to think about any algebra, I'm just going to work. I see something times something, I immediately think product rule. I got the derivative of the first thing, the derivative of tangent of x, that doesn't scare me at all, that's on my memorized list, times the cosecant of x, cool, no d over dx here, nothing for me to do, plus the derivative of cosecant of x, again, no big deal, that's on my memorization list, times the tangent of x. Got a couple derivatives to take, I take those derivatives and I'm done. The derivative of tangent is secant squared, so I get secant squared x times cosecant of x, plus the derivative of cosecant. Remember, you got the co in there, so it's going to be negative. It's negative cosecant times cotangent. So this plus turns into a minus. I got cosecant of x, I got cotangent of x, and then I still have this tangent of x right here. No d over dx's. I'm feeling good. I'm calling this my final answer. I'm moving on. Okay, that's great. You can do that. This is the right answer. There's nothing wrong with this. However, this simplifies quite a bit. How do I know this simplifies? Because I believe this simplifies. So what I'm saying is if we didn't immediately tackle this thing with calculus, if we took a second to kind of breathe and stare at this thing and ask ourselves the question, could we simplify this before we even start the calculus? I think we'll end up with a much simpler expression here to take the derivative of. Tangent of x is the same as sine of x divided by cosine of x. Secant of x is the same as 1 divided by sine of x. This sine of x and this sine of x cancel out. This question is really just asking me, what's the derivative of 1 over cosine of x? And you're like, wait a minute, 1 over cosine of x, isn't that just the same as the secant of x? Absolutely it is. This question is really just asking you what's the derivative of secant of x, which you might have memorized is secant of x times tangent of x. If you do your algebra ahead of time, that can make the calculus super easy. We don't end up having to use the product rule in this problem, although this is the same as this, so it really doesn't matter which way you do it. It might surprise you that the thing in red is equal to the thing in pink. Let me prove that to you by simplifying the thing in red here. This should all be considered kind of optional work. Secant is the same as 1 over cosine. So instead of secant squared, I can write 1 over cosine squared x. Cosecant is the same as 1 over sine. So instead of writing cosecant of x, I can write 1 over sine of x. From that, I want to subtract cosecant, which again is 1 over sine of x, times cotangent, which is cosine of x over sine of x, times tangent, which is sine of x over cosine of x. Not a whole lot works out over here, but over here things simplify really nicely. This cosine and this cosine cancel, this sine and this sine cancel, so what I'm left with is 1 over sine of x times cosine squared x, minus 1 over sine of x. It's still not obvious that this is equal to what we have in pink here, but one way you could prove that is by getting a common denominator. If you multiply the top and the bottom here by cosine squared x, then each of these fractions would have a denominator of sine of x times cosine squared x. And if they both have the same denominator, I can subtract their numerators. I get 1 minus cosine squared x up top. 1 minus cosine squared x, is that a thing? Yeah, it's absolutely a thing. Come back up here to your Pythagorean identity. Think about what would happen if you subtracted cosine squared from both sides. You'd have 1 minus cosine squared on the right side, and you'd have sine squared on the left side. What I'm saying is 1 minus cosine squared x is the same as sine squared x. So I get sine squared x over sine of x cosine squared x. Now I can cancel this sine of x and one of these sine of x's, and I get sine of x divided by cosine squared x, which I can rewrite as 1 over cosine of x times sine of x over cosine of x, because 1 over cosine of x is the same as secant of x, and sine over cosine of x is the same as tangent of x, and what we've shown is that our answer in red, by doing all the work in green, is the exact same as our answer was in pink. It's easy to get overwhelmed. If you look at C here, you're like, whoa, that's the hardest problem I've ever seen. But if you really think about the calculus, it wasn't that bad. I mean, even in option 1, where the calculus was as hard as it could be in this problem, all it was an application of the product rule. That's not that big of a deal. And if you're lucky enough to be a little bit good with your algebraic trig, you can simplify this expression before you ever get going, and your calculus ends up being super easy. Just figure out the derivative of secant of x. To be clear, any of these lines that don't have d over dx written on them is a perfectly acceptable answer. I just think some of them are a little bit prettier, so maybe a little bit better than others, although all of them would be equal. One more example in this video. In the last video, I talked about how sometimes the second derivative ends up being relevant. So for that reason, I want to get a little bit of practice figuring out second derivatives. To figure out the second derivative, the process is pretty easy. You just take the derivative of the derivative. So if f of x equals cosecant of x, my first step would be to figure out f prime of x, the derivative of cosecant of x. Hopefully that's something that's on your memorization list. You're like cosecant, so it's going to be negative. Maybe you think that secant is secant times tangent, therefore cosecant is cosecant times cotangent. At least that's how I remember it. And in just one line, you can come up with the first derivative. Unfortunately, figuring out the second derivative is going to be a little bit more complex. The reason why is the second derivative is the derivative of the derivative. So it's the derivative of negative cosecant of x times cotangent of x. We got a product, we're going to have to use the product rule. What I would probably do is think about this as negative 1 times cosecant of x times cotangent of x. Take that negative 1 out in front using our coefficient rule, and think about negative 1 times the derivative of positive cosecant of x times cotangent of x. You don't have to do that, but I think pulling the coefficients out in front make it less likely that you'll make a little mistake with the signs. I got negative 1 times. I'm about to use the product rule, so I better open up some parentheses. The derivative of cosecant of x, whatever that ends up being, times cotangent of x, plus the derivative of cotangent of x, whatever that ends up being, times cosecant of x. Think derivative of the first thing times the second thing, plus derivative of the second thing times the first thing. Are these all derivatives that I can take? Absolutely they are. The derivative of cosecant, it's got the co there, so it's going to be negative. I think derivative of secant is secant times tangent, therefore derivative of cosecant is cosecant times cotangent. That's how I remember it. So this derivative produces all of this, but don't forget you still have this cotangent over here. And then to that I want to add the derivative of cotangent. Because it's cotangent, it's going to be negative, so I'll change this plus sign into a minus sign. I think the derivative of tangent equals secant squared. Therefore, I know that the derivative of cotangent is cosecant squared. You don't have to remember them that way. That just works for me. And then don't forget you still have this cosecant over here. Could be done at this step if you wanted to. It's just not the prettiest thing in the world. Instead, maybe take the negative and distribute it through. That makes everything positive. That's cool. And then instead of writing cotangent times cotangent, you might as well write cotangent squared. Similarly, instead of writing cosecant squared times cosecant, you might as well write cosecant cubed x. I don't believe this simplifies a whole lot, although I don't know how you would know that. So maybe you would try to simplify it by, I don't know, changing everything into sines and cosines, and then seeing if things cancel out. But I don't think they will, because cosecant is going to be 1 over sine, and cotangent is going to be cosine over sine. So the sines are kind of all end up in the denominator, and there'll be cosines in the numerator. So I won't be able to cancel anything from the numerator and the denominator. I guess one thing that you could do is factor out a cosecant of x, because that appears in both of these terms, and that would leave you with cotangent squared x plus cosecant squared x in the parentheses. Whether this is any simpler than this, I don't know. I guess it's just personal preference which answer you like better. I kind of like this one because I like the symmetry with these both being squared. But that's not saying this is any better. It's just kind of prettier, I guess. Anyways, those are the type of examples that you'll be doing in this section.